Hello everyone, my name is S.K. Karthikeyan, Associate Professor, Kongunadu College of Engineering and Technology. Today we are going to see few topics in kinematics of machinery subject. In the unit 2, that is in unit 2 kinematics analysis of simple mechanisms, we are going to see a topic that is instantaneous center of rotation. That is nothing but a combination of a rotation and translation of a link in a arrangement or a mechanism may be assumed to be a motion of pure rotation about the center I. That is, it's a virtual center of rotation. For example, you have one car. In the slide you see one car is moving on the road. That is, the wheel going to rotate first and the linear translation also achieved by the car. So it's a combined effect of rotation as well as translation. Okay, this is the one more example we're going to see. Here you have two diagrams. The first diagram you can see a link AB. The ends are mentioned as A and B of a link that going to attain a new location by translatory motion A1 B dash. The AB attain a new location A1 B dash. Then about the center of A1, the B dash going to rotate furtherly. So it going to attain a new location A1 B1. So this is first thing, that is translation then rotation. The another example diagram is rotation then translation. You see the AB link, the end B going to rotate about the center A, that is end A, and it going to attain a new location B dash. Now the position of link is A B dash. Then it furtherly move linearly and going to attain a new location A1 B1. So these are all the examples for a instantaneous center of rotation. Then the next one is we have one formula, mathematical formula for finding the number of instantaneous center. That is notated by a letter capital N. You know very well, small n is for finding the number of links. Small n is for number of links. So the formula become n equal to n into n minus 1 divided by 2. And coming to next one, this is how to find or locate or mention a instantaneous center for the arrangement. In the picture A and B having the same two links 1 and 2, and both the things are connected at the point A. In the A picture, the link 1 is fixed link, that is having a hatching, that means it's a fixed link, that is joined with the 2 at the point A. The link 2 having the rotation about the point A, and link 1 is fixed. So the instantaneous center is the joining of two links having the instantaneous center, that is I1 2. Then second picture, that is B picture, both the links having a rotation about the center A and they have a connection at the point A. So the instantaneous center is I1 2 here. Then coming to next one, this is the one more example of arrangement. There is a slider on the floor. So the floor is fixed one, that is mentioned by a hatching line there, and you going to consider a point A or B in the slider, means that the velocity is in the x-axis and the y-axis is you not having the defined location, defined path, that is it's a infinity one. So the instantaneous center is I1 2 at infinity. Likewise you have to mention. Then third one is two rollers or a roller on the floor. First one is a roller on the floor is the first example. So the roller is mentioned as 1 and it's a fixed one. Over that the roller is going to rotate. So the point of contact between the two having the instantaneous center. The second example is one roller rolls over another roller. So the point of contact having the instantaneous center I1 2. Likewise, you have to mention all the instantaneous center for the arrangement. Then coming to the types, we have three types. one is, first one is fixed instantaneous center, second one is permanent instantaneous center, then third one is neither fixed nor permanent instantaneous center. Now we going to see what all the things are fixed, permanent, and neither fixed or nor permanent instantaneous centers. As usual, we take one example, that is 4-bar arrangement. You see in the corner of the slide diagram, a 4-bar link arrangement having the link name as 1, 2, 3, 4. So the total number of links are n equal to 4. As usual, we have the connection of two links are marked by the letters, that is A, B, C, D letters. So in the 4-bar, we also mentioned the instantaneous centers. That is, the link joining portions A, B, C, D are marked by the instantaneous center. That is I12, I23, I34, I14. Then with that, we also going to mention the imaginary points, the extension of the two links as shown in figure I13, I24 also marked. So as usual, you start from the finding of number of instantaneous center using the formula n equal to n into n minus 1 divided by 2. So you substitute n is 4 here because we have 4 links in the arrangement. So 4 into 4 minus 1 divided by 2. So there is 6. So totally this arrangement having the 6 instantaneous center. So we going to categorize the by naming, categorize the number of instantaneous centers by naming. That is fixed, permanent, neither for fixed or nor permanent instantaneous center. Here we have in the diagram, we have the first link is the fixed portion, that is having the hatching. That means it's a fixed link. So the instantaneous center related to that first link or fixed instantaneous centers, that is I12, I14 are related to the first link. So this is these two are mentioned as fixed instantaneous centers. Then second one, except fixed the other links having the instantaneous centers, that is I23 and I24. So these two are the permanent instantaneous centers. Permanent instantaneous centers. Then next one is neither fixed nor permanent instantaneous center. That is the imaginary, the extension of the links I13, I24. These are all named as neither fixed nor permanent instantaneous centers. So totally we have come to 6 things, 2 in the fixed instantaneous center, 2 in the permanent instantaneous center, and 2 in the neither fixed nor permanent instantaneous center for the given arrangement. Then coming to the calculation, that is when you go for finding the velocity of a link, means you have to follow some steps for finding some basic terms. In the step 1, you have to calculate the number of instantaneous center using the formula n equal to n into n minus 1 divided by 2. So for the 4-bar arrangement, that going to be 6, that is 4 into 4 minus 1 divided by 2. Finally you got capital N as 6. So totally 6 instantaneous center you are going to achieve. Then second step, you have to make a column, that is tabular column. In that you mention all the 4 links 1, 2, 3, 4 and you keep something in the, you have to maintain something in the column. So the first one is column 1 is for first link. You have to list out all the instantaneous center related to the first link I12, I13, I14. That start with the link 1, I12, I13, I14. So all the links are started with the first name, link name. Then the second column you mention the second link related instantaneous centers I23, I24. Then third column third link related instantaneous centers I34. So totally in the by formula we got 6 instantaneous centers. All the things are listed in the tabulation. So this is the step 2. Then step 3, you have to mark which one is permanent, which one is fixed by making a tick. So we know the one related things are I12, I14 are fixed instantaneous centers. Then the other things I23, I34, these are all permanent instantaneous centers. So that to also make a you have to make a tick. So the remainings are neither fixed nor permanent instantaneous centers. So this is the third step. Then the fourth one is you have to follow the Kennedy theorem. That is, you have to draw a circle, and you have to mention all the four links in that by drawing a square, and you mention the instantaneous center. When you join 1 and 2 means the instantaneous center is marked at the center I12. Then 2 and 3 I23, 3 and 4 I34, 4 and 1 I14. Then the diagonal connection of 2 and 4 is I24. Then the diagonal connection of I, that is 1 and 3 is I13. So these are all marked by the marked in the circle diagram. Then after that you have to do some calculation for by using the concept of angular velocity ratio theorem. So this ratio theorem state that the angular velocity ratio of two links relative to the third link is inversely proportional to the distance of their common instantaneous center from the respective center of rotation. That is, for example, take the same 4 bar arrangement, and you have the numbering 1 2 3 4 A B C D, everything you have to done first, and you simply mark the instantaneous center, all type of instantaneous centers. Now I like to find the velocity of the link 2, that is velocity of BA. That is nothing but angular velocity of the second link into the link distance, that is AB. So that is the first thing I have to mention, angular velocity into link distance. That is also written as V2 as omega 2 into the radial distance of I12 to I13. That is one way. Then now you have a diagram in the slide. You see the same velocity of the link 2 is written as omega 3 into the radial distance of I13 to I23. So we have two formulas here. One is related with the angular velocity of 2, another one is related with the angular velocity of 3. So both are equal. So you equate both the equation, and you keep all the angular velocity in one side and remaining things in the another side. So finally you got omega 2 by omega 3 is the radial distance of I13 to I23, and divided by radial distance of I12 to I23. So that is the final thing we can achieve. So using this we can find the velocity of a particular link. So I think you understand all the thing. Thank you all.